Here we go. The first thing that I want to do, look down here on the bottom where I'm going to write. Remember how we had, if we had like x to the fourth times x to the seventh, we would add them together to get x to the 11th, right? Because x to the fourth is x times x times x times x, right? And x to the seventh is times x times x times x times x times x times x times x, okay? If you multiply x to the fourth, or 4x's, times x to the seventh, or 7x's, you ultimately get 11x's being multiplied together, right? And so you add the exponents. We're going to do the same thing, the same idea in reverse with division. Instead of adding them together, you're going to subtract them. Got it? This is just a natural extension of what we've been doing. So let's take a look at the rule up here. It says, you can use properties of exponents to divide powers with the same base. Remember, we have to have the same base, okay? You can use repeated multiplication, like writing it out like this, longhand, to simplify quotients, division problems, quotients, right? Of powers with the same base. So if you have 4 to the fifth, you can write out 4 times 4 times 4 times 4 times 4, and 4 to the third is 4 times 4 times 4. They cancel. Each pair, one on the top and one on the bottom, cancels, and what you're left with is 2 4s on the top, or 4 to the second. Expand the numerator and denominator, then divide out any common factors. Those 4s, what the base is, are the common factors. Okay. This example suggests the following property of exponents. So for dividing powers with the same base, to divide powers with the same base, subtract the exponents. If you have a to the m divided by a to the n, you do a to the m minus n. We're not going to use 0 as a base. Okay, and m and n have to be rational numbers. They could be whole numbers, integers, positive or negative. They could also be fractions, okay, or any kind of rational numbers. You could have decimals as well, but typically you're going to see fractions. So here's the idea. 2 to the sixth divided by 2 to the second. You do 2 to the sixth minus 2, and that becomes 2 to the fourth. Again, if we were to write it out, 2 to the sixth is 2 times 2 times 2 times 2 times 2 times 2 divided by 2 to the second, 2 times 2, and then that cancels that cancels that, and what are you left with? That 2 to the fourth right there. Okay, I won't do that for everyone, but that's how you want to see it. Okay. Actually, I will do it for the next one as well, though, because it's worth seeing this one. Okay, because you can come to a negative number here. You can have x to the fourth divided by x to the seventh, which is x to the 4 minus 7, which is x to the negative 3, right? 4 minus 7 is negative 3, x to the negative 3, which that negative would put it on the bottom. And what does that look like if you wrote this out? It would be x to the fourth on top, over x to the seventh. Sorry, my pen is starting to lose its ability to write. Okay, there's x to the fourth divided by x to the seventh, and you can see if you cancel out. Canceling everything out means you're left with a 1 on top. And that is the x to the third that they have right here, okay? Subtracting them, you get x to the negative 3, which we know puts x to the third on the bottom, which is what you get there, okay? Because there's only 4 x's to cancel on top, and there's 7 on the bottom, so there's going to be 3 left on the bottom. Yeah? Okay, let's keep going. I'm looking at the last one. This one I'm not going to write out. It's a little bit tricky to write out when you have fractional ones, but in terms of how I just did it. But it still works the same. Okay, s to the 3/4 divided by s to the 1/2. You're again, just like here and like here, you're going to subtract. So you say 3/4 minus 1/2. That's the same as 3/4 minus 2/4, because 1/2 is 2/4, right? And now you're subtracting fourths from fourths. 3/4 minus 2/4 is 1/4. S to the 1/4, which we're going to talk about what that means a little bit later and in the next lesson. But that's the big idea. Let's go apply them to some problems. Okay, here we go. What is the simplified form of each expression? Remember what we said we're doing. If you're dividing powers with the same base, we're going to subtract the exponents. What does that look like? That looks like here is we're saying, leave that for a second. We're saying if it says an exponent of 5/2 on the top and a 2 on the bottom, then that's the order that you subtract them in. 5/2 minus 2. Subtract exponents when dividing powers at the same base. And of course, we need to be able to subtract these. So what does that look like for us? Okay. Well, 5/2, if I write it up here as just a little note, 5/2 minus 2 is the same as 5/2 minus 4/2. If I wrote this 2 as a fraction with a denominator of 2, we'd have to put a 4 on the top to make it equal to 2. So then you have 5/2 minus 4/2 is 1/2. Okay? Fractions. And what about this one? Okay, well, notice this. We're going to deal with each base separately. We have a base of m and a base of n, and we're going to deal with each of those separately. And check out what we do when we do it. Okay, we have the m's, their exponents get subtracted, and right here, and so we do m to the second divided by m to the fifth is the same as m to the 2 minus 5. Okay, and for the n's, these n's have the same base, so we say n to the fourth divided by n to the third is n to the 4 minus 3. Now we need to simplify that, but again, just to be clear, what do we do there? We said the m's go together, so we're going to do that. We're going to deal with their exponents right here, and the n's go together, so we're going to deal with their exponents right there and keep that base of m and that base of n respectively. Okay, and now what does it look like when we finish this up? Well, 2 minus 5 is negative 3 for the m, and 4 minus 3 is 1 for the n. Now we need to resolve these. N to the first, we don't write as n to the first, we just write as n. And this m to the negative 3, we're going to put that on the bottom as m to the positive 3. Okay, so we have n to the first, or n, over m to the third, because that goes on the bottom because of the negative, and the negative gets used up in doing it. Got it? Okay, so let's look at your got it problems. There's a bunch of them, but they're going to be pretty straightforward. Oops. And you're going to simplify these by subtracting the exponents if they have the same base, and then write your result using positive exponents, meaning if it's negative, change it to the other side of the fraction bar. Okay, you're going to pause the video here and write your answers down, and then unpause, and we'll come back and we'll talk about the answers in just a second. So pause the video now. Okay, so what do we got here? Well, let's look at A. Y to the 3/4 divided by y to the 1/2. So we say we're looking at y to the 3/4 minus 1/2. Okay, and what we need to do there is we need to change them to a common denominator. If you're going to subtract or add fractions, you need a common denominator. So we make the common denominator of 4. 3/4 minus 2/4. Y to the 3/4 minus 2/4. 3/4 minus 2/4 is 1/4, so y to the 1/4. And let's just circle that as the final answer. Okay. What do we got for D? D to the 7/2 divided by D to the third. So we do d to the 7/2 minus 3. And of course we need a common denominator there. So we say d to the 7/2 minus d to the 6/2, because 6/2 is equal to 3. Okay? And when we do 7/2 minus 6/2, we get d to the 1/2. And that's the answer for that one. Okay? When we have two different variables like we do here, you need to deal with them separately. So how do we write that? We can just write it like this. We can say k to the 6 minus 1, because k is just k to the first. So k to the 6 divided by k to the first is k to the 6 minus 1, and then j to the second divided by j to the fifth is j to the 2 minus 5. When we simplify those, we get 6 minus 1 is 5, and 2 minus 5 is negative 3. So we've got k to the fifth, j to the negative 3, which of course then, if we write with positive exponents, we need to move this j to the third to the other side of the fraction bar, in this case to the bottom. Oops, sorry about that. And we are done with that one, so let's mark that one as well. That is the final answer for that. What about D? Well, again, we're going to deal with these each separately, so we're going to say we're going to take a to the negative 3 divided by a to the fifth and do a to the negative 3 minus 5. For the b to the seventh divided by b to the second is b to the 7 minus 2, and I should have a minus 2 in there. Oh, there it is, sorry. Okay, and so when we come up here, we say, okay, let's resolve that. Negative 3 minus 5 is negative 8, and 7 minus 2 is 5. So the only thing left to do now is to take that a to the negative 8, put on the bottom as a to the 8th, because it has a negative exponent, so we want to jump the fraction bar. B to the 5th stays on top. Okay, and finally this last one, it's more complicated, but it's really just more of the same. Okay, we do the x exponent subtracted, 4 minus 4, 4 minus 4. We do the y exponent subtracted, always the top one first, negative 1 minus 5. Oh, and actually, you know what? I made an error here. Can you see what my error is? I'm going to give you a second to catch my error, and then I'm going to zoom in on it and I'm going to fix it. Okay? Can you see my error? Well, let me point it out to you. What I should have been doing is negative 1 minus negative 5, and I just wrote negative 1 minus 5. I forgot that that negative right here, which is what that sign of that 5 is, negative 5, is not the subtraction part of it, so I need to actually subtract that. So let's take a look at what I wrote and see why it's wrong. Okay, what I had here is negative 1 minus 5 is negative 6, but actually what I should have written, and give me a chance to write it up top to correct it, my mistake, is what I should have had is, of course, x to the 4 minus 4, that part's fine. Okay, z to the 8th minus z to the first, that part's fine. Okay, what we're looking at is this. So watch what I'm going to write up top. What I should write is what we have on top, y to the negative 1, and then I'm going to subtract the exponent from the bottom. So I should be saying minus a negative 5, which actually works out to be y to the negative 1 plus 5, which is actually y to the 4th. Do you see what I did there? I made a mistake. I should have subtracted these two numbers. Maybe you already can see it, and so I'm beating it to death, but I should have done that minus that, and that looks like this up top, which actually then looks like that, which is this. So that y, it's not y to the negative 6, it's y to the 4th. And if I can erase it, let's pick a small one. Okay, that should be negative 1 minus negative 5, or y to the 4th. And then, because the x's go away, x to the 4 minus 4 is x to the 0, that's equal to 1. That y to the 4th is still there, y to the 4th. And that z to the 8 minus 1 is z to the 7th is there as well. That is the final answer. So glad I caught that, otherwise I'd be hearing emails from all of you who are doing hard work and noticing that I'm making mistakes. Okay? If you want me to clarify that one again, I can, but there you go. Let's keep going. Okay, what if you have a fractional base? Okay, that's what they're calling a quotient. A quotient is like you have x divided by y, right? So that's the quotient. That's the answer to that, even though it's just sitting there looking like a fraction. Okay, so when you see quotient, they're saying a fractional base. When you have that raised to a power, what can you do? Well, look at what you do when you're doing that. What you're really saying here is x over y multiplied by itself 3 times. You get x over y times x over y times x over y. And as you know, or as you should know with fractions, when you have these multiplied together, you just do top times top times top, x times x times x, and bottom times bottom times bottom for the bottom, y times y times y. Okay, so then what you get, if you write that with exponents, if you wrote this with exponents, you're multiplying the x together 3 times. X times x times x is x to the third, and y times y times y is y to the third. What ended up happening here? Well, you ended up saying, okay, if we're going to raise this whole thing to the third power, then we're really going to multiply this together 3 times, or give that an exponent of 3, like that, and multiply this together 3 times in the bottom, and just give that an exponent of 3. So it says here then, this suggests another property of exponents. If you are raising a quotient or a fractional base, and you should see that as when they say that, what they're saying is because this is like division, and answer to a division problem is a quotient, so that's what that division problem is equal to as a fraction. Okay, raising that quotient or that fractional base to a power. Okay, to raise a quotient to a power, raise the numerator and the denominator to the power separately, right? X to the third, y to the third, and then you can simplify it out. So if you write this, you say, okay, in algebra you would say if it was a over b to the n, you would have a over n divided by b over n, where the bases a and b, both of those numbers can't be 0, okay, because we're not ever going to be using 0 bases. And we're talking about n being some rational number. We're always here dealing with numbers that are either positive or negative whole numbers or fractions. Could be decimals, but normally not. Okay? Not what you're going to see anyway. Okay, so what does this look like? Well, here's what it looks like when they then are talking about simplifying. They say, okay, if you have 3/5 to the third power, that's just 3 to the third power on top and 5 to the third power on the bottom, which then you can simplify here by doing this, okay, multiplying them out. Now here, x over y to the fifth, x to the fifth on the top, y to the fifth on the bottom. And same thing here with a and b to the 1/2, they each are raised to the 1/2 power. And we're going to see how that plays out in a minute. So let's check out some problems. Okay, so what is the simplified form of this? Z to the 2/3 over 5 raised to the third power. Now, this is multiple choice. They're giving us some choices here. Which one is the answer? But what we're going to do is we're going to just solve this separately, see what we get, and then look for that answer that we got in the multiple choice, okay? So first we say, okay, if we're going to use the rule that we just learned, we're raising a fractional base or a division problem to a power, so we're going to give that to each part. So we're going to say, okay, then z to the 2/3 will get raised to the third, and 5 will get raised to the third. Raise the numerator and denominator separately to that exponent. And then, what do we do here? Well, remember when you raise a power to a power, you multiply the exponents, okay? And a quick refresher on that is if we had x squared raised to the third power, what we were really saying is x squared times x squared times x squared, or x times x times x times x times x times x. Okay, and you can see then that we're multiplying them together a total of 6 times, which corresponds to that exponent and that exponent multiplied together. Got it? Okay, so that's just a refresher on that. And let's clear this out of there and look at the problem then. So when we do that, we say, what is 2/3 times 3 if we're trying to resolve this top exponent? 2/3 times 3. Let's do it over here. 2/3 times 3, or 3 over 1. And you can see that they cancel out. Oops. leaving you with just 2 to the first or 2. So we should get an exponent of 2 right there. And of course 5 to the third. So let's see what we get there. And that z to the 2/3 times 3 is z to the second. That's on top. And 5 to the third power is 5 times 5 times 5, which is 125. And that's what you get. So if we were to then look for that answer up top, where would we find it? We would find it right here. Okay. And you can examine some of the other answers to see what common mistakes might be. If you look at these multiple choice answers, I'm just going to leave you to do this on your own, but it's really worth doing. Like, what did they try and do there? Okay, they got z to the 11/3. What did they do? They turned that into 9/3 and added them? Nope, that's not what you do. They multiplied this by 3. Nope, that's not what you do. Okay, same thing all around. So it's worth looking at. Now, what's your got it problem? So the correct answer is D, of course. Now, what's your got it problem? Okay, what is the simplified form of this? And describe 2 different ways to simplify this. And which method do you prefer? I'm going to talk about both of those methods, and I'll show the answer after you pause it and you attempt your answers. Really, this is a really good one, especially this reasoning problem, because you should be aware that there are 2 different ways that you could do this. Okay, so work on those, pause this, unpause it when you have answers, and I'll go over it. Okay, so what is the simplified form of 4 over x cubed, all raised to the second power? Well, we're going to give that exponent to each part, the numerator and the denominator, like that. And of course, 4 squared is 16, and x cubed raised to the second power is really x cubed times x cubed, or x times x times x, times x times x times x, or x multiplied together 6 times, those exponents getting multiplied. Okay, power to a power. Now, describe 2 different methods for simplifying this expression. Okay, we could do this. We could give that exponent to both parts. We could say a to the 3/4 all raised to the 4th power over a to the 5th all raised to the 4th power. Or we could simplify inside here first. Okay, and what would that look like? Well, that would look like, remember when we're dividing, we subtract the exponents. So I'm going to do that over here on the right hand side. We could say that would be a to the 3/4 minus 5, subtract the exponents, all of that raised to the 4th power. Okay. Now if we did that, we'd have to say, we'd have to have a to the 3/4 minus, what is 5 as fourths? 20/4 raised to the 4th power. And when we subtract those, we get a to the negative 17/4 all raised to the 4th power, and then you multiply those 2 together, and you get a to the negative 17/4 times 4, which this cancels out. These 4's cancel out, and you get ultimately a to the negative 17. Simplest method? Let's see. Let me just mark this. Okay, what happens if we did it over here? Well, if we did it over here on the left-hand side, we would say we're doing power of a power, so we multiply these together. 3/4 times 4, so you get a to the 3/4 times 4 over a to the 5 times 4. And this becomes then a to the 3rd over a to the 20th. And when we're subtracting, when we're dividing, we subtract the exponents. We get a to the 3 minus 20, or a to the negative 17. Which did you find easier? I'll tell you what, for me, all of this, coming up with common denominators and subtracting and having weird negative fractional exponents and multiplying them together seems kind of complicated. Well, I like doing this first, where 3/4 times 4 results in a whole number, and this results in a whole number, and now you're just subtracting two whole numbers. Let me make that subtraction clearer. That to me is easier. This is a what do you prefer? There is no better way of doing it. As you can see, both of these methods resulted in the exact same answer, so it's what you prefer more. You can do it either way. Okay? Let's do a couple more problems and we'll be done. Okay, first, we're going to go over this quick rule. If you have a quotient or a fractional base raised to a negative exponent, how do you rewrite that using positive exponents? Okay, well, check it out. This is true. That definition of a negative exponent takes that thing and puts it on the bottom. Okay? And you can then distribute that exponent to both parts. A to the n over b to the n, right? So 1 over a to the n over b to the n. And of course, dividing, that's 1 divided by this is the same as 1 times its reciprocal. Okay? That's the keep, change, or I think you learned it as keep, change. Okay, so keep that as a 1, change that from division to multiplication, and change that to its reciprocal. And then what you get is, oh, and by the way, you say the same rule that you apply where you can distribute this exponent to both parts, you can pull it out of both parts if it's the same exponent on both of those, and keep that as b over a. Okay, simplify. And now notice what we had. We had this becoming this. I'm going to circle these so that you can compare them for a second. Okay, this is worth watching, and I'll say it real quick again. Okay, you can write this without the negative by putting it over the fraction bar, jumping it to the bottom. Okay, you can distribute that n to both pieces of it, top and bottom, numerator and denominator, and then dividing by a fraction is the same as multiplying by its reciprocal. So 1 times the reciprocal, and 1 times anything just is what it is, so that's what that is. And if they're both raised to the n power, you can pull it out just like you had put it in here. You can pull it back out again. Okay, and what results? You get rid of the negative from here, and you end up with the reciprocal of the base. And here's the big so what? So what's the rule? So a over b to the negative n is the same as b over a to the positive n. For all non-zero numbers a and b, can't be using zeros on the basis, and positive integers of n. Okay, so we will turn that from, and they're saying this is with integers. Okay, now that's the rule. We have a negative in the exponent. We just flip the base to its reciprocal, and we can get rid of that. And we're going to apply that right now to be our last slide. Okay. Simplifying this exponential expression, and specifically simplifying it when it's got a negative exponent out here. Now, what is the simplified form of this? What does it mean to be a simplified form? If you look at this slide right here, it says, how do you write an expression in simplified form? You use the properties of exponents to write each variable with a single positive exponent. So we combine any bases to have the exponent. If it's negative, we change it to positive. Okay. Now, how are we going to approach this? Well, first thing that we should do is we should take the reciprocal so that we can get rid of that negative in the exponent. So instead of a negative third power, we're going to make it to the third power by putting what's on the bottom on the top and what's on the top on the bottom. That's simply, we took the reciprocal of the base to get rid of that negative. Okay, what's next? Oops. Okay, now now that we're here, we say, okay, we're going to raise this to the third power, we're going to raise this to the third power. So raise the numerator and denominator to that third power that's out here. Y to the fourth to the third, and 2x to the sixth to the third. Okay? And when we do that, we say we multiply those exponents. 4 times 3 is 12, so we get y to the 12th. And we raise each piece inside each of the different types, the coefficient and the variable, also to the third power. So 2 to the third is 8, and x to the sixth to the third is x to the 18th. There's nothing to cancel here, so that is the simplified form of it. Okay? So your got it problem is, what is the simplified form of a over 5b all raised to the negative second power? Pause the video here, come up with an answer for this, unpause it, and I will show you what the answer is. So the first thing we're going to do is we're going to deal with the negative. Let's get rid of this negative by taking the reciprocal of this. We're going to put then 5b on the top and a on the bottom, and now we simply have an exponent of 2 instead of negative 2, because the negative was used up in flipping that fraction to its reciprocal. Now we're going to give that exponent of 2 to each part. You can't write this because what is here is 5b. So what you have to write is this, showing that you're raising that whole part 5b to the second power, not just the b. If you don't put the parentheses, that exponent is only acting on the b, not on the 5 as well. And of course, now we have to take that a and we have to give that the second power as well. Okay. When we resolve this, we have to raise 5 to the second power, which is 25, and b to the second power. On the bottom, we've got a to the second power. And that, my friends, is the answer to this got it problem. We're done with this lesson. You might want to review it. Definitely do the IXLs, because that's really going to lock it in. And then do your book problems before the 7-4 homework. Okay, good luck.